talk about Descartes' rule of signs. And Descartes' rule of signs tells us about the positive real roots and the negative real roots. So to look at the positive real roots, we look at the sign change of our original function p of x. So here there is a sign change. So it goes positive 2 here to negative x cubed here. Here it goes from negative to positive. That's also a sign change. And here from positive to negative, that's also a sign change. So this is 3 sign changes, which tells us that there's going to be 3 positive roots. Or we could subtract that by a multiple of 2. So if we subtract 2, that would give us 1 positive root. And if we subtract by 2 again, that would give us negative 1 positive roots, which obviously you can't have a negative number of roots, so that does not work. So we stop there, and our answer would be 3 or 1 positive real roots. Should have included real in there. Now we're going to look at negative roots. So in order to look at that, we need to look at p of negative x. So we need to substitute a negative x for all our x's here in parentheses. So we have 2 times negative x to the 4th minus negative x cubed plus 3 times negative x squared minus 1. And then we're going to use, this exponent needs to be outside the parentheses. And now we need to simplify this using PEMDAS. So exponents first. Negative x to the 4th is actually just positive x to the 4th. Since anytime you have a negative to an even power, it's going to come out positive. Negative x times negative x times negative x times negative x is positive. So this will be 2x to the 4th. Negative x cubed would be negative times negative times negative. So that's going to become negative x cubed times the negative 1 in front will actually make it positive x cubed. Negative x squared, it's even, so it will stay positive, plus 3x squared minus 1 doesn't change. So now we need to look at the sign changes. This is not a sign change, this is not a sign change, and this is a sign change. So we have 1 sign change, which means that we have 1 negative real root. Or we could subtract that by a factor of 2, which would give us negative 1 negative real roots, which does not work. So in this case, we just have 1 possibility. It must have 1 negative real root. And the reason we subtract multiples of 2 is because anytime you have a possible root, but it doesn't turn out to be real, would be if it's an imaginary. And we know based on the complex conjugate theorem, if we have 1 imaginary root, we also must have its conjugate. So since they come in pairs of 2, we subtract off multiples of 2. Just to give you guys another example, if we did this problem and it had 5 sign changes, our possibilities would be 5 sign changes, 3 sign changes, or 1 sign, or 5 positive real roots, 3 negative real roots, or 1 negative real root. We would keep subtracting 2 until we break that 0. So just as an example, for future problems, you always keep subtracting 2 off to signify these pairs that complex or imaginary solutions come in to find out how many real solutions there could be.